flip this can over into this ice water, that steam, that water vapor is going to convert to a liquid water. And believe it or not, remember we said 14.7 pounds per square inch on this can? The air pressure is just going to collapse this can. Do you believe that? You give it a go. Here we go. See what happens. See that? How that just collapsed? Also forced water inside it. Let me try that again here. Here we go. Wait, this one more time. There you go. Pretty cool, huh? So, you ever hear meteorologists talk about, high air pressure creates beautiful warm weather, and low pressure creates storms and whatnot? Okay, so let me demonstrate that. Here's a syringe with a plunger in it, and we'll have you as your volunteer step on up here. Anybody had a shot before? Most people have.
You didn't get a shot there, Jerry.
Okay, so when I put this plunge in here and I plunge it down, what do you think happens to the pressure? What do you think when I squeeze on this? What happens to the pressure? It goes up, right? What do you think happens to the temperature? Anybody want to take a guess what happens to temperature when you increase pressure? Yeah, go ahead. No, it's the opposite. So what happens when we increase pressure? What happens to temperature? Go ahead. It goes higher, right? So go ahead and see the graph right here. We've got pressure here, we've got temperature here, okay? So just give this a good push, and we'll see what happens. See how temperature goes up with pressure? Do it again. Pretty amazing, isn't it? I'm going to turn this off. Turn this down. So here's a Q-tip. You've all used Q-tips before, right? I'm going to take a little piece of cotton, like so. I'm going to put in this little tube here. And it's pretty dry up here, so I got a lot of static electricity. Let me try this again. There we go. So you see a little piece of cotton in there? So I'm going to increase air pressure. Like so. There we go. So for that cotton to light on fire, how hot do you think it has to get? Any idea? Like 800 degrees, 900 degrees? What do you think? I think it's got to get over about 700 degrees or so for that cotton to catch on fire. So what happens when I increase the pressure in this tube? Do you think I can increase the pressure enough to cause that cotton to catch on fire? What do y'all think? We have some skeptics here. Who thinks this won't work? So we got a few people here who think it won't work. I congratulate you on your challenge there, right? So here we go. So what I'm going to do is I'm going to increase air pressure enough, and that little piece of cotton's going to catch on fire. All right? You guys ready? Okay, here it goes. One, just got to hit this thing pretty hard. 1, 2, 3, go. See it? Good catch. You can see the smoke, right? Okay. Now, so when we increase pressure, what happens to temperature? Goes up. So when we have an area of high pressure moves over Los Osos, what do you think happens to temperature? Goes up, right? Sunny, clear days, absolutely beautiful weather. What happens if temperature decreases, or actually pressure decreases? Ever heard of area low pressure when meteorologists talk about an area of low pressure moving in, a storm moving in? What do you think happens to temperature? If pressure increases temperature, what do you think when pressure decreases, what happens to temperature? Does it go up or does it go down? It goes down, right? When temperature goes down, that's when you start getting clouds and rain and precipitation and everything else, okay? So we'll have you, what's your name? Elizabeth, come on up here, Elizabeth. Okay, I need you to do this. We'll have you pump this pump up like this. Think you got it? So go ahead and pump it as fast as you can. You don't think you can do that? You want to get somebody else? We'll have you. What's your name? What's your name? Brian? Okay. Ryan with an R. Okay, come here. Just pump this thing up. There you go. Keep it going. Give it about 5 good pumps. And what I'm gonna do is gonna let the pressure out here just briefly. Okay, here we go. Are you guys ready? So you see the cloud in the bottle now? So when you have area of high pressure, you get sunny and beautiful weather. When you get area of low pressure, you get clouds and fog and mist and maybe some rain. You'll really use some rain, right?
Yeah.
Devin, what's your question?
There's actually some water.
Yeah, sure. I mean, I could drain the water out. There's still a little bit of mist in here, right? Good point, Devin. What do you think happens when I increase the pressure in this bottle? What's going to happen to that mist? What do you think? Think it's going to clear up? See how this cleared up? There's no more mist in there, right? See how area of high pressure, the temperature increases, and all the precipitation goes away. Now what happens when I release the pressure?
The horse? Okay.
You get another cloud in the bottle, right? So there you go. All right, yeah, go ahead. You had a question? Oh, 5 more minutes? Okay, go ahead.
That still has some water in the bottom, like the cans did, and you use the bottom, and you flip it over.
I try to get all the water out of here, right?
Yeah, but if you like have some water in the bottom,
Yeah.
like the can, and they really rub it, you flip it into water, it's gonna.
Well, need to really convert all that water into water vapor, and then you get the crushed can. But yeah, same thing would happen here. I'm afraid though the plastic would probably melt, so that's probably the consequence there. Okay, let me do one more thing for you. I had that balloon, what the heck? Oh, it's right over here, okay. This is kind of fun. Got the water balloon. I think I'm running out of breath, you guys. Blown up too many of these balloons. I can use the pump, that's a good idea. Okay, so here we go. So what's going to happen when I put this flame on this water in this air balloon? What do you think?
It's probably off.
Probably pop, right? What do you think?
I'm probably thinking that it's probably gonna fly because if you heat up the air in a balloon, it's like a hot air.
Yeah.
Heat up the air, it's gonna float.
Absolutely, Brett. That is really a good analogy because a hot air balloon, you heat up the air. The hotter the air, the less dense it is, and away it goes. But with this one, if I put this flame to this balloon, it's going to pop, right? You know. Now, what do you think is going to happen if I put this flame to this water balloon? Think it's going to pop? What do you guys think? It's not going to do anything? What's your name? Yeah. Ellie? Good observation. So Ellie thinks that when I put a flame to this water balloon, nothing's going to help. Nothing's going to happen, right? What do you think? Ryan, you think it's just going to burn it? Do you think it's going to leak water? No? Who thinks it's going to leak water? You think it's going to make a big mess here right in front of all of you? Okay, so some of you guys think that this thing's going to burst and it's going to pop and water's going to go everywhere, right? But some other people are thinking that nothing's going to happen. What do you think?
I think it's just gonna boil.
You think? See what happens. Okay, here's the flame. Kind of nothing happening, right? I could probably hold this flame here for the next 5 or 6 hours, and the latex will never pop. Because that water has so much more heat capacity than the air does. Kind of like, think about this as the ocean. The ocean has 1,000 times the heat capacity than the atmosphere does. All right? So last but not least, I think we got like 2 minutes left. Who goes hiking here? Does anybody go hiking? I know Mr. Snap goes hiking quite a bit. And if you ever go in the Los Padres National Forest, actually Los Padres Wilderness area behind Cuesta Grave. You may see these kind of milk carton sort of, you know, styrofoam boxes hanging around. You guys ever seen one of these back in the backcountry? I have a friend who's got about 33 of these in his garage. So every morning at 4:30 in the morning at Vandenberg Air Force Base, they launch one of these weather balloons. They fill them with helium. So at sea surface, they're about 9 feet in diameter. By the time these things get up to about 100,000 feet, they're almost as big as this overhead. And what happens is that as this thing's going up to the atmosphere, it's taking this radio song along with it, and it's got a humidity sensor, a GPS, temperature sensor, and pressure sensor, and it's just all broadcasting the information back to us so we can see what the weather's going to be like. Now, when the weather balloon finally pops, this will come flowing down a little parachute, and some of these radio songs will have return addresses and some of them won't. So if you happen to be camping or backpacking or hiking, you may come across one of these radio songs. And what they are is meteorologists use these to determine what the weather's going to be like, how to forecast the weather. So there you go. I just want to say thank you so much, and I hope you have your next station here is coming up shortly.